Now we discussed the invertible. I want to compare to the causality, the causal. In the case of the causal, we made the xt is the big phi b is a wt. It was the infinite summation of the white noise. So we describe it was the MA representation. It's a MA form because it is the infinite summation of the white noise. But the other way, we are going to take the infinite summation of the x's. So now we can describe it is the AR form, it's an AR representation. So here is only the white noise. So because of that, we are going to multiply the pi b, is another operator. It's similar as the big phi b. We multiply the pi b onto the xt. And similar as the phi b, which was the infinite summation of the big phi j and bj, but here's the pi b. Yep, look at this one, it's a similar one. And also the big phi 0 was 1, and here is a pi 0 is a 1. And the main thing is we have to check the infinite summation of, yep, be careful again, here is the absolute value of the pi j. It must be infinite. Sorry, Fahrenheit is less than infinite. So now we have the same example is here, and we are going to check the invertibility. So now let me make the form, the general form. It must be 1 minus 0.9b is xt is equal to 1 plus 0.5b is wt. So now I can say it is the phi b xt is equal to theta b is a wt. So now we are going to apply this one is into here. I mean the into here. Okay, so we plugged the pi b xt was it's a wt. I mean this one is into here. So now it will be phi b xt is equal to theta b pi b is xt. So now, as we did, as before, we cancel out the white noise, right? But now we cancel out the xt, and let me rewrite. Now then it will be 1 minus 0.9b. It will be same as the theta b here was. And now let me multiply the pi b, which will be the pi 0 b0, pi 1 b1, pi 2 b square, and let me write one more, 3b cube is a forever. So now let me make the multiplication. As you know, the pi 1 was 1, and the power 0 is 1 again. So with the 1 and 1, it will be 1. And now the 1 and the pi 1 b with the b term. So here is the pi 1, and between these two we can make another b term. It's a plus, it's 0.5b. And again, it's a 1 and b squared. It's a pi 2 b squared. So here's a pi 2. And between these two, it's a plus, it's 0.5 pi 1 b squared. And I can expect the next one is it will be pi 3 plus 0.5 pi 2 b. How many power? 3. It's forever. So now we can cancel out this 1 and 1. And between this one, that one, yeah, I can say pi 1 plus 0.5 is negative 0.9. And the others, it must be 0. So it's a pi 2 plus 0.5 pi 1 is equal to 0. Pi 3 plus 0.5 pi 2 is equal to 0 too. And let's keep going. So let me take from here. The pi 1 must be negative 1.4. And now here pi 2 will be negative 0.5 pi 1. So now I can say it's a negative 0.5 and negative 1.4. And now here's a pi 3. It's another negative 0.5 pi squared and pi 2. Then it will be, I have here is a negative 0.5 and here's a negative 0.5 again. So it must be negative 0.5 squared, negative 1.4. And I can expect the next one will be negative 0.5 pi 3. So it will be negative 0.5 cube is negative 1.4. Okay, so now we need the infinite summation of, remember, take the absolute value of the pi's from 0 to infinity. So we have to take the pi 0, absolute value of the pi 0, absolute value of the pi 1, and absolute value of the pi 2, and keep going. The pi 0 was 1, so let me plug 1. And you know the pi 1 was negative 1.4, so let me take just 1.4. Pi 2 was a negative and negative is a positive, so we don't care the sign. So it just is a 0.5 and 1.4. It's the same thing. The next one is a pi 3. It's a negative. Square will be positive and negative, but we don't care the sign. So simply the absolute value of the pi 3 will be 0.5 square and times is 0.4, and let's keep going to infinity. So finally, the summation will be 1 plus, what is the first term? 1.4. 1 minus, who is the multiplier? It's a 0.5. So you can take the answer, but it must be less than, it's infinity. So what is the conclusion? Let me go up. Yes, here. This one. The model ALMA 1 and 1 is invertible. Because we showed the infinite summation is Fahrenheit. It's not infinite.